Fine, you can have questions that would give you the average speed, or the speed of an object is this particular value, then the time is this particular value, calculate the distance and all that. So for those kind of questions, you usually have the speed as the average speed. But if we are interested in knowing what actually happened during the motion, like from the beginning down to the very end, did the car stop at some point? Did we have an issue? When was the car moving with a constant acceleration? When did the car decelerate? So for those kind of detail, that level of detail, you really need to get used to distance time graphs. That would give you a good picture of the motion of the object. Distance time graphs, it's a graph that shows you the speed of an object. Okay, you can get the speed of an object via using the gradient of a line. There will be another video on how you guys can use the gradient of a line to get the speed, but the focus here is just to show you some of the concepts of distance time graphs. So on the y-axis you have distance traveled, and on the x-axis you have the time taken. Then you plot the graph right in the middle. Okay, so here you have the sample of a graph. We've highlighted 5 different points which we're going to look at here. Now for point A, at A, the object is traveling at a constant speed. The line is steep, but not too steep. Okay, so you have something of this nature. Okay, kind of close to the x-axis, but not too steep. Okay, that gives you constant speed. So that means the speed is not changing, it's the same throughout that particular point. And if you have a situation where the graph looks like what you have for B, that's like just a curved line, pointing upwards, that is synonymous to when the object is now starting to accelerate. When we say accelerate, that means the speed is changing but at an increasing rate. Then for a case of C, you have the graph, very steep. Okay, very steep. So here it's still traveling at a constant speed, similar to what we had for A, but the only difference is the object is moving a little bit faster this time around. Okay, and we have a situation for D, point D. That's where you have the object decelerating. You have a curve, something like this. The object is now starting to decelerate. That means the speed is changing this time around, but at a decreasing rate. That means the object, or we can say the car or the particle, is now coming to rest. Okay, it's not at rest yet, but the speed is changing at a decreasing rate. And lastly, at point E, the object is stationary. Okay, the object is stationary, is at rest, it's not moving. The line is like completely flat. So what you have here, you have something like this, like completely flat. Okay, not curved, completely flat. Now in that situation, you can see that, oh, the object is at rest, it's not moving, acceleration is 0, speed is 0. Okay, it's not moving. So that's it, guys, for this video. I'll definitely see you in future videos, so have a great day.